Exercise 2.1, question number 5. The question is, if A is a matrix having elements 1, 2, 0, minus 1, B is another matrix having elements 2, 3, minus 1 and 1, and we have to show that A plus B whole square is not equal to A square plus 2AB plus B square, and the second part is A minus B whole square is not equal to A square minus 2AB plus B square, and the third part is A square minus B square is not equal to A minus B multiplied by A plus B. The formula hold for the that is A plus B whole square is equal to A square plus 2AB plus B square when or A minus B whole square is equal to A square minus 2AB plus B square, or A square minus B square is equal to A minus B multiplied by A plus B when A, B are real or complex numbers. In case of matrices, the condition is failed to hold. So for the calculation of these statements, we apply a counter example. The matrix A, the order of the matrix A is 2 cross 2, and the order of the matrix B is also equal to 2 cross 2. The addition for the matrix A with the matrix B is possible, because the condition for the addition of matrices is possible only when the order of these matrices are the same. Add the corresponding elements of these matrices. Add 1 with 2, 2 with 3, 0 with minus 1, minus 1 with 1. The resultant quantity is 3, 5, 1, minus 1 and 0. Now to calculate A minus B, for the subtraction of matrices, the matrix A is this one minus the matrix B is this matrix. For the subtraction of matrices, the subtraction is possible only when the order of these matrices are the same. So the order of the matrix A is 2 cross 2, and the order of the matrix B is also equal to 2 cross 2. Subtract the corresponding elements. After the simplification, we get minus 1, plus 1 and minus 2, which is equal to A minus B. Now to calculate A square, the matrix A, the multiplication of the matrix A with the matrix A is possible only when the matrix A is a square matrix. So the matrix A is a square matrix. The order of the matrix A is 2 cross 2. Multiply the matrix A with itself. Multiply the first row with the first column. 1 multiplied by 1 plus 2 multiplied by 0. The resulting quantity is 1 plus 0 is equal to 1. This element is obtained when we multiply the first row with first column. First row and first column. Multiply the first row with second column. Multiply 1 with 2 plus 2 multiplied by minus 1. The resultant quantity is 2 minus 2 equal to 0. This element is obtained when we multiply the first row with second column. The resultant quantity is will be in substitute in first row and second column. Multiply the second row with first column. 0 multiplied by 1 plus minus 1 multiplied by 0. 0 minus 0. Resultant quantity is equal to 0. Row is second, column is first. Multiply the second row with second column. 0 multiplied by 2 plus minus 1 multiplied by minus 1. 0 plus 1. Resultant quantity is 1. Row is second, column is second. Row is second and column is second, which is equal to A square. B square. To calculate B square, multiply B with B. The order of the matrix B is 2 cross 2, and the order of the matrix B is also equal to 2 cross 2. The matrix B is a square matrix. The matrix B is multiply 2 with 2, 3 minus 1, 4 minus 3, 1 row first, column first. Multiply first with second. 2 multiplied by 3 plus 3 multiplied by 1. The resultant quantity is equal to 6 plus 3. 9. Row is first, column is second. first and second. Multiply the second row with first column. Minus 1 multiplied by 2 plus 1 multiplied by minus 1. Minus 2 minus 1. Row is second, column is first. Multiply second row with second column. Minus 1 multiplied by 3 plus 1 multiplied by 1. Minus 3 plus 1 equal to minus 2. Row is second, column is second. B square. Now multiply the matrix A with the matrix B. The order of A is 2 cross 2 and the order of B is 2 cross 2. The column of the first matrix is equal to the rows of the second matrix. The multiplication is possible. Multiply the first row with first column. 1 multiplied by 2 plus 2 multiplied by minus 1. 2 minus 2 0. Row is first, column is first. Multiply first row with second column. 1 multiplied by 3 plus 2 multiplied by 1. 3 plus 2 5. Row is first, column is second. Row is first and column is second. Multiply second row with first column. 0 multiplied by 2 0 multiply by 2. 0 multiply by 2 plus minus 1 multiply by minus 1 plus 0 multiply by 3 plus minus 1 multiply by plus 1. This quantity is equal to 0 plus 1 and 0 minus 1. Now AB is equal to, this quantity is equal to plus 1 and this quantity is equal to minus 1. Now to calculate 2AB, multiply this, the matrix AB is, elements of the matrix AB is 0, 5, plus 1 and minus 1. Multiply with the scalar 2. Multiply each element by the scalar 2. We have 2 multiply by 0 plus 2 multiply by 5. 2 multiply by plus 1 plus 2 multiply by minus 1. This quantity is equal to 0 plus 10 plus 2 minus 2. Now to calculate A plus B whole square. A plus B whole square is equal to A plus B multiplied by A plus B. The matrix A plus B is A plus B. The resultant of A plus B is a matrix having elements 3, 5, minus 1 and 0. Substitute this quantity, this matrix here. 3, 5, minus 1 and 0. Multiply this matrix with itself. We get A plus B whole square. The matrix A plus B is a 2 cross 2 matrix, which is a square matrix. So multiplication of a square matrix with itself is possible. Procedure for the multiplication is 3 multiplied by 3 plus 5 multiplied by minus 1. 3 multiplied by 5. 5 multiplied by 0. Multiply the second with first column. Minus 1 multiplied by 3 plus 0 multiplied by minus 1. Minus 1 multiplied by 5 plus 0 multiplied by 0. A plus B whole square will be equal to, after the simplification we get 9 minus 5, 15 plus 0, minus 3 plus 0, minus 5 plus 0, which is equal to 4, 15, minus 3 and minus 5. This is your equation number first. Now to calculate A minus B whole square, multiply A minus B with A minus B. A minus B is this matrix. Multiply this matrix with itself. The same procedure, adopt the same procedure for the multiplication as explained in our previous steps. A minus B whole square is equal to the matrix having elements 0, 3, minus 3 and 3. This is your equation number 3rd. Now to calculate a square plus 2ab plus b square. A square is equal to 1 0 0 1 plus 2ab is a matrix equal to 0 10 minus 2 2 plus b square is a matrix having elements 1 9 minus 3 and minus 2. Add these matrices. The order of these matrices are the same. Each matrix is equal to 2 cross 2. Add these matrices. Add the corresponding elements. The resultant matrix is equal to having elements 2, 19, minus 5 and 1. This is your equation number 2nd. From equation number 1st, a plus b whole square is equal to is a matrix having elements 4, 15, minus 3 and 5. And in the second equation, compare the element in the first row is 4, 15. Here the element in the first row is 2, 19, which are different. And the element in the second row is minus 3, 15, and the element in the second row is minus 5 and 1, which are different. So a plus b whole square, this matrix is not equal to a square plus 2ab plus b square, the resultant matrix, which is not equal to this matrix. So from equation number 1st and equation number 2nd, we have a plus b whole square is not equal to a square plus 2ab plus b square. Now to calculate a square minus 2ab plus b square, the matrix a square is this matrix minus the matrix b, and this is the matrix c. First we have to add and subtract, apply the operator subtraction and addition. The order of these matrices are 2 cross 2. The subtraction and addition are possible. The procedure for the subtraction and addition is 1 minus 0 plus 1, 0 minus 10 plus 9, 0 minus 2 plus 2 plus minus 3, which will equal to minus 3. 1 plus 1 minus 2 minus plus minus 2. The resultant matrix is a matrix having elements in the first row is 2 minus 1, in the second row minus 1 and 3. This is your equation number 4. Compare equation number 3rd. A minus b whole square is this matrix having elements in the first row is 0, 3, and in the fourth 2 minus 1, which are unequal, and the element in the second row is minus 3, 3, and the element in the second row is minus 1 and minus 3, which are unequal. Therefore, from equation number 3rd, a minus b whole square is not equal to a square minus 2ab plus b square. Now, to calculate a minus b, multiply by a plus b. A minus b is this matrix and a plus b is a matrix. To multiply these two matrices, the multiplication is possible. After the simplification, as explained in our previous steps, the multiplication of these matrices, we get a matrix having elements in the first row is minus 2, minus 5, and 5 and 5. From equation number 5 and 6, this is your equation number 6. This is your equation number 5. A square minus b square. Subtract a square minus b square. This is matrix a square and this is the matrix b square. We get this matrix. The corresponding element of these matrices are unequal. The order is the same, but the corresponding element are unequal. Therefore, we conclude that a square minus b square is not equal to a minus b multiplied by a plus b.